Okay, we're going to look at one-dimensional arrays, but this time this will be part 2. So we're going to look at how to pass a one-dimensional array to a function, how to search a one-dimensional array, how to access an individual element in a one-dimensional array, how to find the highest value, how to use parallel one-dimensional arrays, and also we're going to look at the explanation of a bubble sort algorithm. In the advanced portion of, I guess you could say this class, C++ or Java, you will actually look at many different algorithms, and but for this particular class, we're just going to look at one sort algorithm, and it's not the most efficient algorithm, but it's an algorithm, okay, usually used with small arrays. So we're going to go all the way forward to this slide. So in programs, we got to have functions. We want to divide things into separate functions. So at times we might need to pass an array to a function, and the thing that you're going to find out is that when you pass an array to a function, the arrays are always passed by reference. So remember earlier when I was drawing the picture of the grades array, the actual grades variable holds, the name grades holds the first memory location of your array. And from then on, it uses the subscript to calculate the next or the location needed. So anytime that we pass the array, it's always going to be passed by reference. It would be very inefficient if we tried to pass it by value, because it would require us to copy the entire array, and sometimes arrays can be very large, like you can have hundreds of variables, so it would be very inefficient. So you always want to pass it by value. Passing an array by value allows the computer to pass the address of only the first array element. And like I said earlier, since elements are stored in a contiguous memory locations, computer can use this address to locate the remaining elements. You indicate that you're passing an array by entering formal parameters name and data type, followed by empty square brackets. We don't use the AND operator because it's already passing by reference. We already have the address. The variable itself holds the address. It doesn't, the word grades holds the address. It doesn't hold a value. So we don't need the AND operator. So let's go ahead and, before we look at this example, this is for our calories program. We're going to create our own function for the program we're working on. So here what they're doing, they're using the function to display the array. So let's do the same thing. We're going to create our own function to display the array. So instead of displaying it here, we're going to create a function to do this. So we'll call it void display. I'll call it display grades, and then I have to pass it the actual array grades. So grades is an integer array, and I can either type in grades open and close brackets, or I don't need the name, I could just have the brackets, but I gotta have the brackets. The brackets are necessary, but the name of the array is not necessary. It's optional. Just like the name of any other variables that I wanted to pass, I could pass here. So I'm just going to pass it grades, And then that's my prototype. This is my function definition. Here I do need the name, and I'm going to have open and close brackets. And again, it's passing the address, or it's passing the address. So I don't have to define this the same name. It doesn't have to be called grades. It can have a different name if I want. And so I'm just going to grab this code here that displays. And I'm going to put it here. So this for loop is going to go from 0 to less than 5, and it's going to display all the grades. And it's going to, oh, and I haven't called it. I need to call it. So I have to call the function. That would help. Let's just put it, call to display grades. Display grades. And I'm going to pass it grades. Okay. So when I pass grades, I don't put any brackets, but I need the brackets here. And some name can be grades or a different name. Here I don't, the name of the array is optional, but I gotta have the brackets. And now when I run it, it should do the same thing. Nothing should change. And it gives me my average of 96.4. And this, where it's showing me the average, it's here in the function that I added. And it did the same thing here. So here they created a display array function. In this particular one, they actually centered the number of elements. And let's see. I don't know why they centered the number of elements. They're not using it anywhere. From 0 to less than 5 plus equals 1. Yeah. So they gave it this variable num elements, but I don't see them using it here. This would be useful if you didn't know how many elements there were in the array. So let's say that you were entering grades, and you were adding to see how many grades were entered. So let's say you were doing a while loop while the user didn't enter -1. So if you kept a counter and it adds up all the, the number of grades you entered, then you could pass it to here, and it would be useful to use in the for loop, but there's no use here for that. And then in this program, in this calories program, they show how they averaged they accumulated here the calories, and then they returned total divided by num elements. So they returned the average. So total divided by num elements. And that was in the get average function. So they created another function that took in the array. And in this case, they have num elements. And here they actually use num elements. They just didn't use it in that other function that we looked at earlier. So here, if they would have used num elements right here, could have put num elements. All right, so that's this program. The next thing we're going to look is how to search an array. So let's say that you wanted to search the array and maybe you wanted to find if they made it a 100. Okay, so that could be one search. Or maybe you wanted to search for the highest grade, or you wanted to search for the lowest grade. Or if the program has names, you want to search for a name. You want to search for the name Joe. That could be another type of search. So in this particular example, we're going to look at an array to store the results of a poll of 25 people who were asked to estimate the average of minutes they spent on Facebook each day. The program allows the user to determine the number of people spending more than a specific number of minutes. Okay? Let's make this bigger. So we're going to enter search for minutes. And then we have a for loop here that goes from 0 to less than 25. It's increasing by 1. If we are at 0 less than 25, we're going to look at the array and see if the value in the array is greater than the search for minutes. So did they spend more than the number of minutes? If it's true, we count it. If it's not true, we don't count it. We're just counting to see how many people spent more than a specific number of minutes. So here's the example that they have. Here's the array, and they've populated the array. These are the number of minutes that people spent on Facebook. And then here it's going to ask the user search for minutes over what. So do you want to search to see how many people were on it more than 50 minutes, more than 30 minutes? So the user gets to decide. And then we have a for loop that goes from 0 to less than 25. And it looks at each one of these and it compares minutes to this. So let's say that the user enters to see who was on Facebook more than 30 minutes. Okay, so we take a look at the very first one. Poll results sub 0 is 35. Is 35 greater than 30 minutes? Yes, that's true. So we would add 1 to our counter. Then sub goes up to 1. 120. Is 120 greater than 30? Yes, we add 1. 75. And it goes on. 20 is not greater than the 30 minutes, so then it doesn't add 1 to the num over. Okay, so this is one search. Basically what you're doing is you're having a for loop. It's going to go from 0 all the way to the end, and then you have an if statement that compares, and it compares to what you're looking for. So let's do that with our program. So how about we check to see if they have any failing grades? Okay, so here instead of displaying all the grades, I'm just going to display the failing grades. That's it. So I'm going to say if grades sub x is less than, say a failing grade would be less than 60. If it's less than 60, then I want to actually see out that value and see what the failing grades are. So I'm not going to keep a counter like they did. I'm just going to see out only the failing grades. Okay, so I'm going to run it. I'm going to enter 70. I'm going to enter 59, 50, 100, 90. So my see out statement here, see out a 59 and a 50, and those are my two failing grades. Okay. So that is how we search for something. And of course, when you're searching, you can say, is it less than? Is it equal to? Is it greater than? Maybe you're looking for a specific number or name. So here we're looking at how to access an individual element. In this particular example, the program displays the name of the selected foreign currency and the converted result on the computer screen. The program uses a 4-element array to store foreign exchange rates. So these are the exchange rates right here. One is Euro, 2 is British, 3 is German, and 4 is Swiss. So if you want to see the exchange rate for euros, then it would be rates sub 0. British would be rates sub 1. So what they've done here is they've had a nice little menu. So if I enter a 1 here, then I want to go into rates sub 0. So they say if the choice equals 1, then you see out euros. And then here you take the dollars. So let's say that it's $100. You multiply that rates. Choice was a 1 because it's euros. 1 minus 1 is 0. So it's going to multiply by 0.92. So my $100 is going to be less in euros, right? For every dollar, I get 0.92 what's worth in euros. So that's how we would access that individual element, is by figuring out which one I want. And if they enter a 1, I have to subtract 1 to get to the first element in the array, which is this one here. Okay, so how do we find the highest number or the lowest number? The program displays the highest number stored in a 4-element array. We can do that with our grades program. The program uses a program-defined value returning function to determine the highest grade. So they have an array with 4 numbers, and they call this function called getHighest. They pass it the array, the number of elements, which is 4, and then what they do is they assign int high. So what you do first is you say, okay, the first number is going to be the highest. Okay, you assign it to high. You got to have a starting point, something to compare. And then what you say is, starting at 1, so starting with the second number in the array, you say, okay, is the second number in the array biggest than the first number in the array? If it is, now the highest is the second number. Go back up. Say, is the third number greater than the highest? If it is, then the highest is changed to the third number. And we go on, so on and so on. So let's go ahead and add this to our program. Okay, so here is where we're displaying the grades. And so let's just change it up, and instead of displaying the grades, we just display the highest grades, the highest grade, not grades. So I'm going to do a for loop. Just going to delete this here. Okay, so the first thing that I need is a variable called high. And that variable is going to be the very first element in my array. The first element in my array is grades sub 0. Okay. So I've assigned this to be the highest. Then I'm going to start at the second element, grade sub 1, and I'm going to stop at less than 5. And I'm going to compare if grade sub x, so this is the first element, if that is greater than what I think is the highest, which is the first one, then I gotta change the highest. The highest is now grades sub x. So for example, if I have, let's say my grades are 90, 85, 100. Let's just look at these three right here. So this is grade sub 0, right? So grade sub 0, high is 90. This is high right now. Then x is 1, so grade sub x is 85. So it would say, is 85 greater than 90? That's false. So it's going to go back up. X will be 2. Grade sub x is now 100. Is 100 greater than 90? That's true. So now the high is changed to the 100. So now this is the high. And we're going to compare this to the rest of them. If I find another grade that's bigger than 100, then high changes. And so now I'm going to see out the highest grade is high. Okay, so 89, 78, 100, 90, 95. The highest grade is 100. The average of the grade is 90.4. Looks like I need a new line right there. But it found my highest grade. What did I just do? Okay, so same thing with low. I can find my lowest grade. Maybe I want to drop the lowest grade. And so I would just change this from greater than to less than. And to not be confusing, I would change this to the word low and the word low, these variables here to low, and then just flip my sign. Okay. Now we're going to look at parallel arrays. So let's play from the current slide. Two arrays, I'm going to read it down here first. Two arrays are referred to as parallel if their elements are related by their position in the array. This is the important part. Two arrays are referred to as parallel if their elements are related by their position in the arrays. What does that mean? Well, let's say that I have grades, but I also have so let's say that I have grades and I have every grade that I enter here is related not to one student, but to different students. So this grade 89 is for student number 1. This is student number 2, student number 3, student number 4, student number 5. So I can create an array that keeps those student names. And then those are called parallel arrays because student 0 will have grade 0. Student 1 will have grade 1. So this will be string student names and 5 of 5 students. Okay. So here, where it says enter a grade, we could say enter a student name. CN student names sub X. Okay, so we ask them to enter the name, enter the grade, enter name, grade, name, grade, name, grade. Okay. And now let's keep the highest grade, but let's output the name of the student who had the highest grade. Okay, so I'm going to need int grades, but I'm also going to need string name, student names add it up here. So my prototype looks like my header. I have student names. Let me see if I've done anything wrong so far. Oh, I gotta also pass it here. Okay. So far, it's okay. So far, so good. No errors. So the next thing I'm going to do here is I'm not just going to output the highest grade. I'm going to output the name also of the student. So the highest grade is whatever it is for student student is okay. So I feel like I deleted something I didn't. Okay, so the student is student names. Now what am I gonna put here in the brackets? Well, I have to keep track of the subscript of who's the highest. So here I'm keeping the highest grade, the high grade, but I also need a variable to keep up with the high subscript. And I'm going to assign it to 0. Okay, so the first time the highest subscript is 0 because that's the highest grade. But every time it changes here in this if statement, I'm also going to change the subscript. So the highest grade changes and the highest subscript also changes. And it changes to X. So now I have access to the highest subscript. Subscript. So I'm going to say Joe made a 90. Mary made a 78. 79. Carla made a 95. Mark, 88. And Tommy, 89. Okay, so our highest grade is Carla with an 95. So the highest grade is 95. The student is Carla. The average of the grade is 88. The student is Carla. We need a little inline there to make that prettier so it's not all. Okay, but it gave us the highest grade, 95, and it's Carla. So this is our parallel arrays. Okay, we've searched our parallel arrays and just remembering that they're related by their position. So there's going to be an example that you can look in here in parallel arrays. The next thing that we're going to look at is, which is the last thing, is how to sort an array. And sorting an array just means we take the data and we put it in an order, either from small to high or high to low. If we're looking at names, we could sort them by A, B, C, D, E, F, by alphabetical order. Numbers, also alphabetical order, could be backwards from Z to A. And so let's take a look at what we call a bubble sort. So there are many types of sorting algorithms. Bubble sort provides a quick and easy way to sort items as long as the number of items is relatively small. Like I said earlier, if you have a really big list of items, you don't want to use a bubble sort because it's very inefficient. But this is the easiest sort and the first one that you always learn in the Intro to Programming class. It works by comparing adjacent array elements and swapping ones that are out of order. Continues comparing and swapping until the data in the array are sorted. So we compare the first and the second, and we swap. If, let's say, we're going from low to high, if the first one is bigger than the second one, we swap. And then we look at the next two and we swap, and we keep swapping and looking at all the elements and swap through them. So here basically they've gone through and they've kind of shown you, if we have an array and it has these numbers 9, 8, 7, what are the steps, the comparisons? So the one thing I want you to notice is that there's a first pass and a second pass. So what that means is that if you have an array, let's say that you swap the first and the second number, and then the second and the third, and then the third and the fourth, and you keep swapping like that. That's your first pass. And it doesn't mean that you've completely put the numbers in order. You have to pass through it again and do it again and again and again until finally you haven't swapped any numbers. So here they compare 9 and 8, and they swap they're going from low to high, so they're swapping the 8 and the 9. And then they compare the 9 and the 7, and they swap because the 7 is smaller, so it goes before the 9. So this is the first pass. So you have 8, 7, 9, but you're still not in order, so you have to do it all over again. Start at the beginning, and then it swaps these two, the 8 and the 7, and we're at 7, 8, 9, and now we're in order. But you can tell and see if you had a really large array, you would have to have many separate passes to be able to finally get your desired result of low to high or high to low. So earlier we taught in one of the presentations we talked about how to swap two numbers, if you have two locations. And the reason we talked about that is because swapping two numbers is important in dealing with sorting data. And if you remember, it required a temporary variable, temp variable. So here is where they do the swapping. And one of the things that it's important is this right here, where it says swap equals yes, because finally, when you get to the last pass and you don't do any swapping and it's set to no, then you know that you're done. You haven't, you need to stop. So if swap equals yes, then we go in and we swap, and then it says max sub equals last swap. Go back through. If this swap changes to, if this swap doesn't get to yes, so if we never go in here and we don't set this to yes, if it stays at an n, then this loop stops and it exits. So here in the next slides, you'll just have some examples of looking at just different, what happens as you're swapping some numbers. I'm not going to go through all these, but what I would do is